Welcome viewers. In this video I shall provide the steps to finding angle Y. We are given a circle with center O and the angle here as 52 degrees. As I go on, please bear it in mind that the whole diagram is not drawn to scale. Now, there are 5 basic theorems I am going to apply in order to get angle Y. The first theorem is to see that this is a cyclic quadrilateral. For a cyclic quadrilateral, the 4 ends touch the circumference of the circle. So for a cyclic quadrilateral, the sum of the opposite interior angles is equal to 180 degrees. So the angle here plus the angle here is 180 degrees. So if we subtract 52 from 180 degrees, 180 minus 52, that gives us 7 minus 5, there is 2. That gives us 128 degrees. So the angle here is 128 degrees. I have applied the first theorem. The next thing I'm going to do is to get the angle here and the angle here. What does these two signs tells us? Those two signs tells us that this triangle is what? Isosceles. And for an isosceles triangle, the base angles are what? Equal. So these two angles here are equal. So let's get those two values. Now 180 minus 128 will still give us back the 52 degrees. So these two angles will share the 52 degrees equally. If you divide 52 by 2, you will have 26 degrees. So this is 26 degrees and this is also 26 degrees because they are base angles of this isosceles triangle and base angles are equal. Next, can you see this sign? Can you see this sign? What does those two signs tells us? They are signs for parallel lines. This line is parallel to this line. And when we have a transversal crossing parallel lines, when we have a transversal crossing parallel lines, alternate angles are what? Equal. There is a Z here, a Z angle. So for that Z, the alternate angles are equal. The angle here is equal to the angle here. So if the angle here is 26 degrees, we can equally say that the angle here is what? The same 26 degrees. This is the Z. So from that Z, we are seeing the alternate angles which are equal. The next theorem I'm going to apply here is angle in a semicircle. If you are given a circle and the diameter, and then you have a triangle on that diameter, the base of the triangle is the same as the diameter. This is angle in a semicircle and it is 90 degrees. The angle here is 90 degrees. I could equally draw it by this other side. The angle here is 90 degrees. So we can see that from here. We can see that from here. Angle in a semicircle is 90 degrees. The whole angle there is 90 degrees. So how do we get this? 90 minus 26 will give us that value. When you subtract, you would have 64 degrees. So the angle here is 64 degrees. So finally, the last theorem I'm applying is what? Sum of angles in a triangle is 180 degrees. 64 plus 52 plus this unknown angle Y is 180 degrees. Now when you add 64 plus 52 degrees together, you would have 116. So subtracting 116 from 180 would give, here we have 4. 7 minus 1 is 6. So subtracting that, we would have 64 degrees. The value here is 64 degrees. So the solution to our Y is 64 degrees. Thanks for watching. If you find the solution very interesting, kindly subscribe to my channel.